So there's three forms of the if statement. There's if, right? If x, then do y. That's one form. There's if x, do y, else do z. That's another one. Or there's if x, do y, else if x2, do y2, else if x3, do y3, else z. Right, like that. And we saw a demonstration of that with the grade program, right? If grade is greater than or equal to 90, they made an A. Else if the grade is greater than or equal to 80, they made a B. Else if it's greater than or equal to 70, they made a C. Else they made an F. Poor people who had a D, we just ruled them out. So those are the three basic forms of if. I see where they're going with their quiz question. If by itself is in fact a valid one. If else is in fact a valid one. They're wanting us to say if not is invalid, but you can actually write an if not statement. The exclamation mark means not. So, you know, I could write this if x equals 10, but I could also write if not x equals 10. That means if x is not equal to 10. So, I don't agree with their quiz question. I should just delete the quiz questions entirely from the PowerPoints because their quiz questions are absurd. What I would normally do, though, I would prefer to write that as if x not equal to 10. That's normally how people write it. But this method works just as well. If not. So this means if not x equal to 10, in other words, x not equal 10. All right, chapter 3 is where the fun actually begins. We start doing real programming rather than talking about pseudocode and flowcharts. So let's do that. I could probably just start the entire semester with chapter 3 and tell people to read chapter 1 and 2 on their own, honestly. But you see how I do it is I lecture over stuff before it gets in the book, so I don't mind doing it that way. So Java Basics, our first Java program. Not really. Here we go. Hello world. Every Java program is going to be wrapped up in a class, unlike Python, unlike the C++ language where you don't have to put things into classes. The file name and the class name have to match. You can put more than one class in a single file, but only one of them can be public. So as we go on, we may wind up creating more classes than just one, put it in the same file name, but only one of them will be marked public. And that's the one that the application can actually launch. inside each class, there will be maybe some data, maybe some methods. A method is a function, what you call functions in other languages. We will always have a class that has a main method, and the syntax of the main method has to match this exactly, or else the program will not run. So we should memorize this. Even though NetBeans creates it for us automatically, we should have that memorized, because you won't always have NetBeans in front of you when you're doing your programming. Because you could just use Notepad to write a program. It's public static void main, parentheses. It looks a little bit like a gobbledygook because we don't know what that means, unless you've taken C++, but it means an array of strings. So to make our code more readable, we use comments. If you use /*, it starts a multi-line comment. You can just keep adding comments line by line, but then when you finally end it with a */, that marks the end of your comments. And our editor colorizes them, right? Makes them green or red or something like that in order to make it easy to read. This is just a really fancy way of doing it. You would not have to add all those asterisks. It would be just as good a comment as if it looked like that. And then there are single line comments. Single line comments are the ones where you just use // followed by some term. And in Python, we were using that as our single line comment. So style requirements. I don't actually demand this, but include a prologue section at the top of every program that consists of a line of stars, a file name, the programmer's name, a blank line, a program description, a line of stars, and a blank line. You know, I could demand that. Just as long as you put your name in the program, you know, which homework assignment it is up at the top and what it does, I'm happy. I don't care if there's a line of stars right across the comments. So all Java programs must be enclosed in a class. The name of the class matches the name of the program. Excuse me, the name of the class matches the name of the file. Proper style dictates that class names begin with an uppercase letter. Just do that as a matter of course. Every time you make a new class, make it start with an uppercase letter. I mean, it'll work without it, but just do it. It's good. It's good style, right? It's like, you know, wearing shoes into a restaurant. It's a good idea. So since Java is case sensitive, the file name will also begin with an uppercase letter. Case sensitive means that the Java compiler does distinguish between lower and uppercase letters. If we do this, A equals 3, and then I try to print out A, but I make it lowercase, it's going to be a syntax error. Once something is created with an uppercase variable name, it has to be uppercase wherever you refer to it. So you always have to have the word public in front of our class so that the code inside is accessible from outside the class. Otherwise, Java will not be able to launch our program. That's why we have public class hello, or public class homework 2, or public class lecture C. Inside your class, we're going to have some methods. We're always going to have a main method. We will add more as we need them. For now, we'll probably just be doing small programs that only need one method. When the program starts, when Java tries to run our program, it looks for the main method. We have to specify the main method if it hasn't found it already. If I ran it and it couldn't find the main method, it asked me to pick which class had the main method in it when I was trying to run my code. We use the braces to group things together. It sounds nebulous. Group things together. It groups blocks of code. For example, in the whole Hello World program, the top and bottom braces contains the contents of the entire class. The interior braces group the contents of the main method. So there we go. Our entire class is defined within these braces. And then within these braces is all the code that's part of the main method. And of course you can have other braces, right? If we have an if statement, and we could have another block of code in here that's subordinate to the if statement, you know, blah, 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 blah. And so this body of code is applicable and determined by that if statement. the whole thing, all of the stuff between those braces is part of the main method. And then the part of everything between the very first curly brace and the very last curly brace of the class is all part of that class. So, proper style dictates. They want you to do this however other people do it other ways. Place an opening brace on a line by itself in the same column as the first character of the previous line. What they're saying is, if I open up an old project, or I could make a new one, huh? They want this curly brace on its own line, like that. I prefer that too. However, by default, NetBeans is going to be creating them where the curly brace is on the same line. That's why it looks like that after I created this file, whenever I did. You can dictate, you can control how Java, how NetBeans does that. If you feel like changing it, if you feel like changing it so that when NetBeans is adding code, they put the braces on their own lines, you can go to Tools, Options. I hope I can find it fast. Editor, Formatting, Braces, and change all of these to new line. And we can see the difference it's making over here, right? Class declaration, I want the curly brace to be on the same line. It would move the curly brace there. I want it on a new line, half indented. Well, that's a very crazy one, but I know that some people must do that in the world. Doing it on a new line indented like that so that it matches that and that. No, I knew somebody who did that and it drove me crazy. So let's just make them all, if you're doing this, go into Options, Editor, Braces Placement, or Category Braces, and then change all those to new lines. That way when it creates a new code, it'll be, but you don't have to do it like that. The people who wrote Java want you to do it like that. It'll work as well either way. It's just whichever one you think is easier to read. Your own choice. The textbook tells you to do it that way. I don't care. I'm not going to count you off for doing it the other way. Obviously, that day I did it like that. The reason I like them lined up the way that I was saying is it makes it visually easy to spot, right? That goes with that. That goes with that. To me, that's easier than trying to spot. Well, that one goes with that one, and, you know, anyways. Up to you. So, to display our output, we've been using system.out.println, ln meaning line. Go to the new line when it's done printing. If you leave the ln off, then it'll display the message, but it won't go to the new line. So if we did this, system.out.print, it would print hello world, but the cursor would be left there waiting after the exclamation mark rather than going to the next line. Compilation and execution. To create a program that can run on the computer, we have to compile it. What does that mean? Go, if you're using one of the computers here, or even if you're using one at home, if you're on a PC, hold the Windows key down. That's the one between the Control and the Alt. Windows key R. Hit Windows key R and see if it pops open the Run box like that. Windows key R. And then type in CMD. Then type in Java C and see if it does anything or it gives you an error. Does it do something for y'all? Okay. What that means is that we could write our code and compile it from the command prompt. Now, we're not going to ever do this again, but for now, if you're still happy playing along with me, type in Notepad test with a capital T colon Java. Excuse me, period Java. Notepad space test dot Java. Do we want to create a file? Yep, we sure do. Public class capital T test, it has to match the file name. On the next line I'm going to do a curly brace. Now we're going to do that main method. Public static void main parentheses in parentheses, and inside the parentheses capital S string square brace close square brace args args. And then after you close parentheses, next line, curly brace, and then system, capital S, system dot out dot println, parentheses, quote, hi, exclamation mark, end quote, in parentheses, semicolon, and then two more lines which are just closing curly braces, curly brace there and a curly brace there. And then hit Control S to save your document. Alrighty. Come over here, come back to your command window, and type in Java C space test.java. It compiled it. We don't see that it compiled it. It returned without any messages whatsoever. If we want more information, we could type Java C -v for verbose. Verbose means talkative. Space test with capital T dot Java. Ooh, I did that wrong. Maybe the flag has to go at the end of it. Or maybe it's the whole word, verbose. It is. And there it goes. Look, it showed us a whole bunch of lickety-split stuff when I did that minus verbose. So I'm not going to do that again. Java C space capital T est dot Java. If I had made a mistake, like if I had forgotten, you know, a semicolon, don't make this change, but I'm just going to show you what the error looks like. It says error line number 5, semicolon expected, and it tries to show me the problem. We see these messages in our little output window. So I'm going to fix that. I'm going to put my semicolon back there. I'm going to compile it one more time. Java C space test.java. Now I'm going to run the program. If I do dir, I will see that there is now a file created by that compiler called test.class. This is the output of that compiler. When I ran Java C, which stands for Java Compiler, it created a file called test.class. I can't do much with that. If I do notepad space test.class to try to edit it, whoo boy. Alright, close that. Don't want to mess with that. I can run the test program now by typing in Java space test. Oddly enough, you don't type in Java space test.class. You just type in Java space test and it assumes it's running the class file. And it said hi, just like I told it to do. So that's doing it all from the command prompt. We're not going to ever do that again in this class. Did it work for everybody? Anybody was at least trying to do it? Or if it didn't work?
This computer's giving me problems, but I just had to mess with the command prompt yesterday, and so.
Well, that's okay. This was just to demonstrate. The real takeaway is that to compile, it runs the Java C command. In fact, why don't we add these to our notes? I guess I haven't made many notes, huh? Have I? Alrighty. Java C compiles the .java file to make a .class file, and then Java runs the .class file like this. Java C space test.java makes test.class, and then Java space test runs test.class. There are a whole bunch of command switches you can pass to Java C. You saw me see them when I typed in Java C without any parameters. So if you ever have to adjust something, you want to give it more memory, you want to add something to the source path, whatever, you may have to edit something within NetBeans to make it, behave a little bit differently. I'm just going to close that. I'll never ask y'all to do that again. So the source code file name is the file name followed by .java, and when it is compiled, it makes so-called bytecode. We saw what happened when I tried to edit that bytecode. It looked like gobbledygook, but it's just a compiled version of that file called class name followed by .class. So identifiers are variable names or other things. The identifier serves as your function names, your method names, your class names, your variable names. They can consist of letters, digits, dollar signs, or underscores. Now, I never see anybody use dollar signs, but you could. If I went into NetBeans, why don't I make a new project? What lecture are we on? E? I think so. Okay, so File, New Project. I'm choosing Java. You can choose Java Ant. Next, Lecture E. I'm going to remove the package declaration there by deleting the period and everything in front of it. Click Finish. I never see anybody do this, like double space price dollar sign equals 3.45. But you can. It's legal. Anyways, valid variable names, also known as identifiers. They can be letters, digits, underscores, and dollar sign. The only exception is that they cannot start with a digit. And if you've taken any other programming courses like C++ or Python, it follows the same rules. Cannot begin with a digit. If you want to be crazy, you could do things like this. Int I, dollar sign, comma, dollar sign, comma, dollar sign, underscore, dollar sign, comma. Right, and then you can make all your variable names look like that. That'd be absolutely ludicrous, but those are valid variable names. I like that. It looks like an emoticon, right? Looks like somebody staring at me with money in their eyes. I don't know. I'm going to get rid of that. So if the first character is a digit, your program won't compile. So valid variable names could be things like tax underscore rate underscore 2019. This is going to sound so familiar to Linda. She just sat through this in a different language. Tax with a capital R, rate 2019, or isn't that enough? Invalid variable names, tax space rate, or 2019 tax rate, right? This is invalid because it's got a space in it. This is invalid because it begins with a digit. So these are okay. These are not. So we could add that as one of our rules. Cannot begin with a digit, cannot have a space. You don't have to use underscores. I tend to use them. You don't have to use uppercase letters in the middle of them. The book tends to use them. So, rules, or it should say guidelines, right? Guidelines. If the next rules are broken, it doesn't break your program, but it's harder to understand, and you'll lose style points on your program. Man, I need to edit these. Where in the world did I get PowerPoints that are written from a professor's point of view, a teacher's point of view with comments like that? These are downloaded directly from the website. So, use letters and digits only, not dollar signs or underscores. Well, I use underscores all the time, but I never use dollar signs, and I've never seen anybody else do it. All letters must be lowercase except the first letter of the second, third, and fourth words in the variable name. First name, capitalize the N. Days in month, capitalize the I and the M. I don't care. When I'm up here, I'm probably not going to capitalize the N in first name just because sometimes people will capitalize it, sometimes they won't, and they'll get syntax errors and they'll slow us down fixing it. So I usually make all my variable names lowercase in these classes, even though this is considered the nice professional modern way of doing it. Addendum to the first rule. Class names should begin with an uppercase letter, but they're the only thing that should begin with an uppercase letter. And the names must be descriptive. Don't use T if you mean temperature. Now honestly, I probably will use single letter variable names in here, and I'm not going to come down on you real hard if you use them in your programs, but just know that the more readable your code is, the better it is. So you should be trying to use longer variable names, not just single letter variable names. Why don't we add that as a comment? Variable names should be descriptive. No single letter variable names except for counters. Or class demonstrations. Smiley face. Because if I'm just demonstrating how multiplication works, I'm not going to necessarily type in something with 10 letters if I can just type in x times y up here. Assignment statements. You use the equal sign to give a value to a variable. Every variable must be declared, has to have a data type, unlike Python, where you just could say salary equals 50,000 without having done any of this stuff up here. If those two lines were missing, it would still be valid Python code, but it's not valid Java or C or C++ or C# or a whole bunch of other languages where you have to declare your variable before you use them. You can declare them and use them at the same time though. We could say int salary equals 50,000. That's fine. If you do that, that's called initialization. When you declare something and assign it a value at the same time, that's called initialization. So int x, that's a declaration. X equals 3, that's an assignment, assigning a value. Int y equals 3, that's a declaration plus assignment, which is called initialization. Or initializing. Now people, I in particular, will use the term initializing when it's not strictly appropriate. I'll say, let's initialize I to 0, and I'll just type in I is equal to 0. We've already declared I way up further in the code, right? But really, technically, if it's not in the same places where it's being declared, it's not initializing. I think of initializing as just the first value that goes into it. All variables must be declared and assigned before they can be used. So if I do this, int x, and then I do int y equals x, that's an error because x, although it was declared, is not assigned a value. X has no value. It will not compile. Alrighty, no writing email because I'm listening to keystrokes trying to figure out when I can go to the next. Alrighty. I'm kidding, you can do what you want, but tracing. Did I do a demonstration of tracing already? Probably not in this class. I really want to skip this, but maybe I won't. Okay, the idea behind tracing is it's kind of running the program by hand in your head. What does that mean? Well, what if we had this program, and don't type this by the way, int x equals 3, while, or int y equals 0, while x is less than 6, in parentheses, y equals y plus x, x equals x plus 1. And then down here we might print out x. Now of course it's really system.writeLine.print. Excuse me, print out y. Okay, so I could run this, find out what it does. What it's supposed to be doing is taking 3 plus 4 plus 5, which I guess is 12. Let's find out if it's 12. Let's see if I've got it right. Normally I do this on a spreadsheet. The people at home are not going to be able to see what I'm doing, so maybe I will do it on a spreadsheet. So I'm going to load up Excel. And I'm going to set up a little spreadsheet that has a value of x and y. Right, so here's x, here's y. Come back. All right, so the program starts off. What's the first thing that happens? X gets assigned a value of 3. What's the next thing that happens? On the next line, y becomes 0. Let's center our data if we possibly can. Okay. So the next thing that happens, y becomes 0. The value of x didn't change, so I'm not changing it. What's the next thing that happens? It's a while statement. Is x less than 6? Is that a true statement? Right now it's 3, so yeah, it is. So we go to the next statement. Y equals y plus x. Well, y is 0, so 0 plus 3, y just changed to 3. X still hasn't changed. Then we go to this line of code. X equals x plus 1. Well, that means that x, which was 3, becomes 4. Y didn't change, so I'm leaving that one alone. Then it comes back and it reevaluates the while statement. Although x went up by 1, it's still less than 6. So it stays inside the while loop. Y equals y plus x. Well, y is 3, but when we add x to it, what's it going to become? 7. Then the next line, what is x going to become? X was 4, so now it is 5. We go up here. Is 5 less than 6?
Yes.
Yeah, sure is. So what is y going to become now when we execute this line? Well, what is y at this current point in time? It's 7. And what is x at this current point in time? So what is 5 plus 7? It's 12. So y changes its value to 12. X changes its value, goes up one more, 6. X is 6. Is 6 less than 6? No, it's not. So it falls out of the while loop and it prints out the answer. It prints out y, which is 12. That's called hand tracing, or tracing the program by hand. You can also trace a program using NetBeans, which is the better way of doing it. What you do in that case is you set a breakpoint in your code, and then you debug the program to that point. So let's actually type that code in that I just had. Int x equals 3, semicolon, int y equals 0, while, parentheses, x less than 6, in parentheses. I'm going to do the short form, though. Y plus equals x, which means add x to the current value of y and store it back into y, and x plus plus, which means increase x by 1. And then why not print out? System.out.println parentheses y equals end quote plus y in parentheses semicolon. What I'm going to do next is known as setting a breakpoint. It's going to stop. It's going to run the program up to a certain point and then stop it so that we can trace it just like we were doing with the flowchart. Excuse me, with the spreadsheet. So where am I going to start my tracing? Why not right here, as soon as the first variable is being created? First, I'm going to Control S it, just so that it has a chance to think everything through. And I'm going to build it to make sure that it's all, why start trying to debug it if it has syntax errors. See if I got it. Success, yeah. Alrighty. I'm going to put a breakpoint over here. How do I do that? I click. Well, I mean, there's a light bulb there kind of getting in the way. But if I go up here and I click on the line number, it makes it red. This is a breakpoint, meaning that when the program runs, it's going to stop there if I run it in debug mode. Clicking the green arrow is not debug mode. It runs it. The next one, though, Debug Project, is debug mode. Or you can always find it up here, which is where I usually do. So now that I have this breakpoint set, I'm going to click Debug Project. It starts the program, and then it gets to this point and it stops. If I open up my window down here, I don't see much going on yet. Let's let it execute the next line. I want it to run one and only one line. So there are some icons up here which control what it's going to do next. You see the one next to the green arrow? If I just wanted to continue, if I press the green arrow, it'd run to the end and print out the result, which is y is equal to 12. That's not good enough. I want to do it line by line, so I'm going to debug the project again. It's going to stop at the breakpoint. You see the symbol next to this green arrow over here? If I hover my cursor over it, it says step over. What that means is completely do that line and go to the next one. It has kind of a down arrow thing. Not quite as much a down arrow as that one, but that one actually means something else. So I'm going to click step over. It goes to the next line. If I hover my cursor over x now, I will see that x has got a value, right? X got given the value 3. If I want to see all the variables, there's a way I can do that, but I'm hold off. I'll do that in a minute. I'm going to step over this line now. I'm going to let it run that line. So I'm going to do the thing next to the green circle. Now y has a value 2. If I hover my cursor over y, it tells me that y is 0 and x is 3. And so the next statement is while x less than 6. I put my cursor on the x, I see it's 3. I can make a good prediction that the next line of code is going to be that one. That's the one that's going to run. So I'm going to click step over one more time. It blips down there. Sure enough, because 3 was less than 6, now it's going to do this. It hasn't done it yet. Y is still 0. But when we step over it, y becomes 3, because 0 plus 3 is 3. And then when we step over this one, 3 is going to become 4, because the plus plus will increase the x to 4. So I'm going to click the step over again. It hit the bottom brace and jumped back up to the top of the while loop so it could check, is x still less than 6? Well, it's 4 now, but that still is less than 6. So when I click step over, it adds 1 to y, or not 1 to y, it adds x to y, it adds 1 to x, so y has gone up to 7, x is now 5, it's still less than 6, so it's going to go to this line again when I click step over. It's going to do that line again. X is going to get 1 added to it, so when it jumps back up to the top of the while loop, x is now 6, 6 less than 6, that's not true, so it's not going to jump to this line. When I let it step over, it's going to jump down here instead, which it did. It's about to print it out. When I click step over, it prints out what we wanted to. And I'm pretty much done at that point. I'm not sure what happens if I keep stepping over after that point. Okay, build successful. I want to make sure y'all are able to do that. That is an incredibly useful skill that I don't emphasize enough. I ought to be making you debug every single time we're in here until you get really, really, really good at it. But so you ought to be able to see a list of variables here and their values. I'm not seeing them, so I'm going to come up to Window, Debug Variables. And then I'm going to drag it down to where it ought to be. Right. So as my program runs, as my program runs, it changes the values of these variables. So now that I've run the debugger again, x, it's right here. X has not been created yet, but when I do step over, it has been. We can see x set to 3. I do another step over. Y has been given the value of 0. I do a couple of step overs here, and the values of x and y have continued to change. And what if I want to be really weird and reset x to -10 or something? I can actually change the value of x. X is now, for whatever purpose, equal to -10. And then if I press the green arrow just to let it continue without stepping, just run through to the end, it will. And now x equal obviously a very different value than it would because I changed the value of x. So the reason why your code did not have a main method is because when you created your project, you chose Maven or something like that rather than ANT. And that's okay, especially if ANT is not working. But if you choose Java ANT, then it creates the file with the public static void main there as well. Either way, doesn't matter. Doesn't take you that much time to type it, but if you can pick ANT and avoid having to do that, so much the better. Now I'm curious. Why use Maven over ANT? The benefits of Maven over ANT are many. Better dependency management. It can identify unused and transitive dependencies. It can create reports. Okay, well, sounds cool. Maybe I ought to learn. Initialization statements. We've already done this. That was just from the example. Anyways, here we're initializing total score to 0. We're initializing max score to 300, or you can do them separately. Int total score is 0. Int max score equals 300. It's okay to use either technique, and you'll see it both ways in the real world. So ints hold integers, meaning whole numbers. The value of an int is from about -2 billion to +2 billion. If you have a number larger than 2 billion, you're not going to be able to store it into an int. Like the population of the planet, 7 billion, 8 billion, 9 billion, I don't know, but it's certainly larger than an int. If you need to hold a value that's larger than int, you use a long. If you've taken C++ and you remember the term long, you can forget that. We just use long. It's a much larger value. It can be 9 followed by 18 zeros. Recommendation. Go ahead and use smaller types for variables that will never need to hold large values. If I'm going to write a program that asks for your weight, I'm probably not going to make it long because I doubt you're going to type in a number followed by 18 zeros. Your weight is probably not larger than 2 billion, so I just use an int. Just use int unless you need it to be larger than 2 billion. That's just kind of your general rule. Let's go ahead and make some notes to that effect, although I'm betting that most of y'all already know what an int is. Int, a whole number, between plus and minus 2 billion. A long is a whole number between plus and minus 1e to the 19, or to the negative 19, right? It can, yeah, like that, 1e to the 19. Is that right? Did I goof that? Let's go look. 18, excuse me. 9e to the 18. 9e to the 18. I'm not going to ask you what the upper limit of a long is, but I do want you to know that an int can hold a value of up to about 2 billion, or negative 2 billion. But what if you need fractional data? Then you need to use a float or a double. A float is a floating point number, meaning it can have a decimal point. And then a double is a double wide float. An integer is 4 bytes wide in memory, meaning that's how much memory is dedicated to holding a single number that's an int, whereas a long is 8 bytes wide. So it's a much larger value. That's why it can hold so many more digits. A float is 4 bytes wide, and a double is 8 bytes wide. We will see pretty soon on these slides the limits of a float. So if you need a decimal point like 123.5 or 3.1452, you use a float or a double. Never use float, always use double. There's no reason to use a float. A float can be like plus or minus 3.14 to 10 to the 38 or 10 to the negative 38. It's only got about 7 digits of accuracy. So like 0.777777. A double can hold vastly larger exponents, right? 3 followed by 308 zeros. And it's got about 15 digits of accuracy. Ooh, I said 7, only 6. So you can see that floats are very imprecise. If you needed to store this number, 0.123456, that's as accurate as a float can get. But a double can get much more accurate, right? Always use double, never use floats. That's just the general rule of thumb. Why don't we even put that into our notes here? So, doubles are also floating point numbers. A float has 6 digits of precision. A double has, what did it say, 15? I believe that's about correct. Doubles hold much larger exponents. .308 rather than just 38. So always use the double to reduce rounding errors. We need to check. Let's see. We have something ready to spring as homework. Nope. Well, guess what I'm going to do? I'm going to give you all my Python classes homework. Of course, I will rewrite it just a little bit for this class. You know what interest is? Like compound interest. You owe $1,000 on your credit card this year. If you don't pay, anything on it, you're going to owe $2,000 on it the next year, and so on. So, here's what the assignment looks like. Compound interest calculator. Here's the formula. P is the starting amount. You owe $1,000 on your credit card, or you start off at $1,000 in your interest earning account. R stands for the rate of interest. 25% is 0.25. 10% is 0.10. N stands for the number of times per year the interest accumulates, like 12 times a year is most common. And T stands for the time in years. So for the purpose of this assignment, just assume that N is 12, since there are 12 months in a year. The requirements. The user will enter the principal, the interest rate, and the number of years and display the result. In Python, this is the expression, but we don't have the star operator, so our expression is going to look a little bit different. So the formula expressed as a Java expression is the same thing, except since we do not have star, we have to do a math.pow function, which I better show y'all before we get out of here. That's the Java version of it. Okay, so what is math.pow? If we want to take something to the power of something else, I'm going to remove that breakpoint by clicking on it. What if I want to find out what 5 to the power of 4 is? Double D1 equals 5. Double D2 equals 4. To calculate D1 to the power of D2, we do this. Double D3, or result, equals capital M, math, dot, POW, parentheses, D1 comma D2, in parentheses, semicolon. That means take D1 and raise it to the power of D2. So that's what the homework's going to be. You're going to write an interest program where you ask the user for the principal amount, P. You ask them for the interest rate, 10. How many years will we calculate? 10. And the total amount including interest is that. For the Python users, I told them how to print that out. I gave them the print statement. That'll do that. I'll do the same for the Java programmers as well, because it's a printf statement, and it looks like this. So the sample formatted print statement is shown below. This is the Python syntax. And here's the Java syntax. System.out.printf, parentheses. We've used printf in here, right?
I don't think we have this much yet.
Yeah, everybody's shaking their head no. Alrighty. Well, let me go ahead and finish this, and then Okay, what does printf do? It lets you specify how the data is printed. If I go back here, I'm going to set result equal to 1.0 divided by 4.56789, something like that. Or why not set result equal to math.pi, capital M A T H dot pi, semicolon. Now we're going to print it out to 2 decimal places. System.out.printf, parentheses quote, pi equals %.2f backslash n, meaning go to the next line. End quote, comma, result. But what if we want more than 2 decimal places, right? 3.14 is not very interesting. What if we want 8 places of accuracy? System.out, just copy and paste that and change that 0.2 to 8. So this one's got 2 decimal places. This has got 8 decimal places. And so when I run it, the first time it prints pi, I'll bring the code back, sorry. It prints out 3.14 because that's 2 decimal places. The second time it prints 3.14159, etc., etc., etc. So this is a formatting string, and this part right here, this %.2f, is a placeholder that gets filled in with that value. And this is a placeholder, %8f, that gets filled in with this value. And we will talk about that again on Tuesday. So even if you write the rest of the program, if you can't get the formatted print statement, the printf to work, that's okay. We'll cover it again on Tuesday. All right, does the homework make sense? Interest calculator, you're going to ask for these values, right? You're going to ask for the principal, you're going to ask for the interest rate, you're going to ask for the number of years, you're going to assume 12 months a year, so you're just going to set n equal to 12, and then you're going to use this formula to calculate that. Does that sound doable? Are we good with this?
Mm-hmm.
Hope so.
I think so.
If you get stuck, ask me about it. If we come in on Tuesday and y'all are totally boggled, then we'll give extra time, right? It won't be due Thursday. But I'm going to make it due, you know, the Thursday, assuming that y'all are going to work on it over the weekend. But if you get totally lost, ask me about it. And if you're still totally lost on Tuesday, then I'll extend the due date. All right. Let's make a Dropbox and be done.